when we've been doing a lot of these proofs, we've been using replacement rule, and not 100% of the time, but very, very often. So something that I, for this one, would like to do is just take this second part. I'll oftentimes start with the first part, but take this second part. Now let's just change it to the measures are equal. So when it comes time to, if we need to replace one for the other, we have that. And the reason we can do that is because the definition of congruency. What does it mean to be congruent? Well, it means all the measures are the same. So if you have two congruent segments, all of the measures of the two segments are the same. And with segments, you only have the one measure. So we made a statement that says the measures are equal instead of naming them congruent. And we're allowed to do that by definition of congruent segments. And now I can replace, if I need to, with the QS for PT or the measure of PT for the measure of QS. All right, now let's go back to the first part. QS, P, and T are collinear. And a lot of different ways you could do this proof, so if you've done this a little bit differently than I walk through it, that's fine. But I usually like to get, we don't have bisects, we don't have midpoint, we don't have any of those keywords to let us know something more specific other than just the two smaller add up to larger. And so you can find that a couple different places. You might see that QP plus PS equals QS, or PS plus ST equals PT. A lot of different things there. And I often say, well, let's try to get them equal to the total. So give me like, I don't know, QS plus ST equals the total QT. Here, they actually give you QS equal to PT. So if you wanted to do the two smaller ones like QP and PS equals SP, well, that might work out because you know that those two chunks are equal. But I'm going to stick to what we've been doing because I think you guys will follow it just fine and it'll work out well for this one too. And I'd ask you guys to give me two smaller segments that will give me QT, the whole thing. So give me two smaller ones that will total the measure of QT. Maybe I'll even get you started. So the measure of QP plus what? What would you have to add to the measure of QP to get the whole thing? Well, you'd be missing, and if you want to pause and try from here, feel free, but I'll keep going if you're not sure what to do, or if you don't want to try that. The whole thing there, PT, that's left over. Put those two together, we get QT. Give me two different things in this situation that give me that same total. QS plus what's left over? The measure of ST. And those are both SAP, segment addition postulate. The two smaller equal the larger. And the reason I did this is because we've done some proofs before where you have a couple at, a couple different angles measure 180, but we have that couple times, and then we're like, wait, we can replace the 180. So that's what we're going to do here. I'm going to rewrite this first equation. You can pick either one, it'll work just fine. But I'm going to rewrite this first equation. The measure of QP plus the measure of PT equals the measure of QT there, but instead of QT, what's the same as QT? Well, replace it with that other sum, the measure of QS plus the measure of ST, which would then be replacement rule. So we have these two sums. They have the same total QT. We'll then set the two sums equal to each other. And if we did this right, we should end up with QP and ST left over. Well, we have a relationship with them. That's what we're trying to prove. But somehow the PT and QS have to cancel out, which, notice in step 2, we changed that so we could replace one for the other. We can change one of those and then be able to subtract it from both sides. QP plus PT plus equals, and you know what? I could have replaced the PT. I'm going to replace the QS with what else equals QS? The measure of PT. That's replacement rule again. And now you can subtract the PT that is on both sides. Again, not the only way to do this. A lot of different ways we could have set this up. I missed the number there. That's 5. We're on 6. What property says you can add or subtract something from both sides so that I could just subtract that PT from both sides? If you want to pause and go look for it, you can. It is the additive property of equality. Add or subtract something from both sides. One last step. I have just enough room because we wanted to say that they're congruent, or state the segment's congruent. They're in the right order, so I don't have to use the symmetric property to change that. Just use the definition of congruent segments to finish this one off, because I've shown all the measures of the segments equal. there is only one measure, and I've done that, which is by definition what it means to be congruent. All the measures are equal, so we can then say that they're congruent.